Welcome back to Math with Patrick. Today is July 11th, and we're solving the 192nd problem from the Daily Epsilon calendar. And the answer today should be 11, because that's today's date. And we're solving for x for 11 here. Okay, we have a system of equations. This one is a linear equation on top. I can tell because there are no exponents or anything like that. And we could do some algebra steps and isolate just the y, and we'd get something like that y equals mx plus b, familiar equation for lines. This is also in standard form for linear equations. Anyways, definitely a line. This one's a little bit different. I believe this is a circle. Circles generally have the equation of x squared plus y squared equals some kind of radius squared. This plus 2y is doing a little bit of something. I believe that's going to be a shift left, as in normally circles of this equation are centered on the origin. I believe that plus 2y is shifting it left by 1 unit. Ultimately, though, once we figure out something about our line and probably our circle, we then need to solve for x, and we're going to find some kind of solution where x plus y is greater than 0. So this third condition makes me think that once we graph it, we're going to have a circle and a line, and these intersection points would kind of give us two different solutions. And then one of these solutions just won't satisfy this condition, and the other one will. Now, before we graph it, though, I want to see if I can solve it with algebra first. Here. So let me change these things into maybe more familiar formats. Here, I want to try to just isolate y to see what happens. I could subtract the 2x to the right side and then divide both sides by 3. So this gives me some expression for the y. And then here, the most familiar way for me to write a circle is in kind of like the complete the square form. So I'll do x squared. Oh, I just realized this is actually a hyperbola. I think I said earlier where circles have this plus between the x squared and the y squared, and hyperbolas have a minus sign. So never mind, we have a hyperbola. It probably still has two solutions, and then we're going to pick one of them based on that third condition. So I should keep the minus sign, and then let's see what I can do here. If I kind of hug these in parentheses, I would also need to negate this one. So I think I'm going to try to find an equivalent expression by doing y minus 1 squared like that. Now this isn't exactly the same as the left-hand side of this equation. That's because if I expanded it, I would get, let's see, y squared minus 2y plus 1. And so this matches because we have a negative y squared. This matches because we have a plus 2y. But then I have this kind of mysterious minus 1 that I just created on the left-hand side of this equation. And so maybe I'll compensate by adding 1 here, and that kept that left-hand side the same. I guess alternatively, I could have introduced a minus 1 on the other side to keep it balanced, and I kind of like that more. I'll say that this is going to be equal to 85. Now, I guess we could do some substitution here. I'm not going to like it that much because subbing in this y value right here is going to be a bit messy, but that seems to be the easiest way forward to me if we're doing it algebraically. I think I want to save graphing for the end. So x squared minus, and then substituting in my value for y, which is 43 minus 2x over 3. I still have this minus 1. I think I'll try doing the common denominator in the next step. So this step that I just wrote down kind of just shows that I'm substituting out the y. Then I could call this 1 a 3 over 3 to match the denominators. And then I can see that the 43 minus the 3 gives me just a 40. A little bit of an easier number to work with. So I get 40 minus 2x over 3 and square that. And then I'll kind of just keep the x squared minus and then the 85 the same. Maybe let's expand this fraction. When you square fractions, you multiply the top by itself and the bottom by itself. So we're going to get 9 down here. And then 1600 minus 160x plus 4x squared. still equal to 85, still have this x squared minus at the start. Let's do another common denominator so we can kind of have these talking to each other. We can bring those denominators together. And then why not, let's multiply that 9 to the other side, just so we don't have any more fractions to deal with. Ooh, and I should be careful here. This minus sign that I have is going to distribute to all three of those terms there. Okay, so 9x squared minus 4x squared is 5x squared. Then how about I'll do the linear term next. I'm going to get plus 160x and then minus 1600. And this is going to be equal to 85 times 9. Let me do the arithmetic and I'll come back. Actually, I'll just pull out my calculator and do it with you. 85 times 9, that is 765. Maybe let's subtract the 765 over here so that we can set it equal to 0. So essentially adding those two numbers together, 1600 plus 765, we get minus 2365. And then let's try finding a greatest common factor. I think we could factor out a 5 from all of these terms. So this 5 goes away. The 160 turns into a 32. And then I can't do this divide by 5 in my head, but fortunately I still have the number on my calculator. Divide by 5 gives me 473. And I guess since we're solving for when it's equal to 0, I could then divide both sides by 5 and then effectively just ignore that times 5 on the outside. And now I'm hoping that this is something that's factorable. And I will kind of cheat a little bit. I do know that one of the answers is 11, and so that is going to help me get the other answer. I know that negative 11 plus something must equal that 32. And so just doing 32 plus 11 gives me 43. And I believe that's the right number to put over there. To double check, I could do 43 times 11, and that does give me 473, and that matches this number here. Okay, that's cool. So we got two answers. If we plugged in an 11 in here, then we would have 0 times 54. I mean, it doesn't matter what the other number is because 0 times anything is 0. Likewise, this could be a negative 43, and we get 0 times something. I mean, that's negative 54. Again, doesn't matter because as long as we make a 0 out of one of our factors, the whole product is 0. So how about let's just open up the graph real quick and maybe visually see why the 11 is the better solution than the negative 43 by kind of taking a look at that third condition. Here's the graph. As you can see, the blue thing is a hyperbola, the red thing is a line. Just to show you, if we do have a plus sign there, it does turn into a circle. Interestingly, this wouldn't have any solution. Fortunately, we did find the two solutions here, and what did I just type in wrong? Oh, is it an 85? Is that what it is? No, wait, hold on. Oh, it's an 86. There we go. I was worried for a sec. Okay, so here's the 11 for the answer for today's date. We could plug in the 11 right here and quickly solve for that 7 for y. And then indeed, when we add these two numbers together, we get something greater than 0. And then this solution, the negative 43 that we found, I'd probably plug it into that linear equation again to find the value for y. It happens to be positive 43. And when we add those two numbers together, we get 0, which is not greater than 0. So ultimately, here's our solution, just this 11 right here, and we're all done. So thanks for watching, and I'll see you tomorrow. Bye.